Once again in this video, I'm just going to tackle a single problem from 7.3 exercise 3, namely problem number 26. This one, just as 25 was, is fairly difficult, fairly tricky, and if you've made it through this one on your own without checking the answer, you're in pretty darn good shape. So let's go through 26 together for those that didn't make it, for those that would like to see it. It does involve a fairly tricky step. We're after U or W and X. Notice the pattern here, just looking at the conclusion, this seems to be the basic pattern of distribution. So let's make note of that, put it in the back of your head. We might finish this problem off via distribution. That's kind of the textbook case of distribution. So let's just jump into the problem. Three premises to work with. What could we possibly do? There's an obvious starting place here. Line number one, the main operator is the dot, so easy enough to take care of that. We can simplify one sim, and that'll get us the A to work with. What can we do with the A? Well, that in turn immediately sets up 2 and 4 modus ponens. So line number 5, we get the consequent of 2 out. We get U or W, and now we're starting to work with the variables here that we're asked to derive in our conclusion. So I'm just going to put a little star next to line number 5 here. I'm probably going to have to return to that. So now what can we do? Well, we seem to be at an impasse. We haven't yet touched line number 3. 3 is a horseshoe statement. The antecedent is an F. And we've got an F here embedded as a part of line number 1. So maybe we can rework line number 1 to get that F by itself, so we can set up a modus ponens, and that would get us a U or X, which again involves the variables that we're after in our conclusion. So the question presently is, how can we manipulate line number 1 to isolate the F? Well, it's going to involve a couple of steps here. We can't do it immediately right off the bat, but one thing we can do to get the F out front, so maybe we can begin to simplify, is a comma. Main operator in 1 is the dot. We've already simplified it. Another rule here we can do when the main operator is the dot is comma. We flip the order. So that will in fact get us the F and L out front. 1 com, flip the order of the conjuncts. We'll get F and L and A. So let's simplify it. That'll now get us the F and L for line 7, 6 sim. F and L. We wanted the F, the antecedent to line number 3, so we just have to simplify it again. 7 this time sim, and we'll get the F by itself. We wanted that now for 3, 8 modus ponens, and we get in the line number 9, we get U or X. So this one probably too going to be a key line to work with, as well as remember line number 5, why I put a star by it. So we originally thought this is the textbook case of distribution. We've got 5 and 9 to work with. So how can we finish this thing off? How can we finish it off? Well, we can't immediately, obviously, do a distribution. There's an intermediate step that we need to take, and this really is the key to the entire problem. If we were to do 5 and 9 conjunction, we will have set up a distribution. So here's what it looks like. Not an easy, obvious step here to make. But with a little bit of thought, we can set up that distribution that we need to ultimately finish this problem off. So again, 5 and 9 conjunction, jam the 2 together with a dot, and we'll get U or W and U or X. Put in the parentheses, clearly identifying the dot as the main operator, and now we've got the textbook case of distribution. Each of the 2 conjuncts has a common variable out front, the U's, so we can suck those out, move it to the outside of the parentheses, leaving behind the W and the X. Main operator starts as a dot, flip that to a wedge, use the dot as a leftover, put it in your groupings, and that's the result of 10 distribution, which now looks exactly like our conclusion. So that was the key step, conjunction here on 10, an easy enough step, conjunction always easy to do, but why did we do it? Why did we need to do it? To set up the distribution to get that conclusion. So that's an easy, fairly straightforward way to solve 26.